Alright, welcome again to Microsoft Academy. So today we are going to be looking at some questions on latent heat. Now, remember when we talk about the latent heat, we are looking at hidden heat. Most of these times you see that when a matter is changing from one phase to another, the temperature change might not be significant or seen in a thermometer. So that hidden heat is what we call the latent heat. So here in this question, we have two questions here. The first one says, what is the amount of heat gained to change an ice of mass 3 kg at 0 degrees Celsius to water at the same temperature? So the specific heat of fusion of ice is given as 3,300 so this 336,000. So we have that in solution, the latent heat is equal to ml, where m is the mass and this is the specific heat of fusion. So here we have the mass as 3 kg, so we substitute this will be 3 times the specific heat of fusion is given as 336,000. So which, if you multiply this will give us. So this is what it will give us in joules. So if you point this in your calculator, you'll be having this. I can decide to write the answer as 1008 kilowatt joules, because from here kilo means 10 raised to power 3. So we do the conversion depending on the option. If you leave the answer this way, it's correct. This is also correct. Now let's look at the next question. The next question here says, how much heat must be added to 50 kg of lead at 30 degrees Celsius to cause it to melt, and the specific heat capacity of lead is given as 130 joule per kilogram per Kelvin. So it melts at 330 degrees Celsius and its heat of fusion is given as 2,000, well, this is 24,600. So how do we solve this? Now this question is technical, but this is how we are going to do it. I will do a little illustration of what we are looking at. So this is what we have. We have a sample of lead and it is caused to melt. So this is the lead material. When you apply heat to the lead material, the lead is going to acquire heat. So the heat the lead will acquire before changing, remember it's in solid state, before it changes to the liquid state. So that heat is given as H equal to MC change in in theta. So when this lead acquires this heat, it will, after some point, it will start changing to liquid. Now, there's another heat or energy that is required to make it to become liquid, and that is the latent heat. So we also have another heat here, so I'll call this one heat 2, call this one heat 1. The latent heat, which is equal to ml. So these are the two heats that are involved in this question, and we have to get the normal heat required and the latent heat before we can get that lead to be converted into the liquid form or to be melted. So that means the total heat in this case will be given as Ht, which is equal to H1 plus H2. So where our H1 is the normal heat required, which is MC change in in theta. Then plus we have H2, which is the latent heat, which is ml. So now from the question, you can see that the mass of the lead was given as 50 kg. So we have the mass as 50 kg. Now we also have the specific heat capacity is given as 130. We have the change in temperature. Here initially was 30 degrees Celsius and now it is 330 degrees Celsius. So here we'll be having the change in temperature is 330 minus 30, which will give us 300 what degree Celsius. And we have the latent heat, the specific latent heat, which is given as 24,600. So which is 24,600. So if we substitute, we are going to see that the total heat will be M, which is 50, times C, as C is 130, times the change in temperature, which is 300. Now we have plus ml. Our m is 50, then L is what? 2,000, 24,600. So if you multiply this, then add up together, this will give us 3,180,000 in what? In joules. So that is the what? Heat required. So with this, we have been able to solve question 1 and what? And question 2 using the latent heat what? Idea. So in the next video, we are going to be looking at other questions that relate to thermal. So now for now we take this one. If you have any question, ask in the comment section. Thank you.